Hello, today we're gonna talk about the recombinant DNA by Mohamed Eltahan. Let's talk about what is the recombinant DNA. Recombinant DNA or rDNA is a technology that uses enzymes to cut and paste together DNA sequences of interest. The recombined DNA sequences can be placed into viruses called vectors. What's the vector? Vector that you that ferry the DNA into a suitable host cell where it can be copied or expressed. So we're gonna talk about the steps of the recombinant DNA. There are 7 steps. First, the steps of the recombinant DNA technology. The bacterial plasmids with a resistance of gene present, usually ampicillin or kanamycin resistant, that are used as vector DNA. So we're going to talk about the steps of the recombinant DNA. There are 7 steps. First step, isolate the DNA sequence gene of interest. Second, we insert your DNA of interest into the vector plasmid. Cut both vector DNA and gene of interest with the same restriction enzymes. So we mix the DNAs, they join by base pairing. Add DNA ligase to bond the pieces covalently, and the result it will be is a recombinant plasmid. That's the second step. Let's talk about the third step. Third step, we're gonna put the recombinant plasmid into E. coli by transformation. So we're gonna say about the fourth step is the clone cells. Clone cells is plate cells onto agar containing apicillin or kanamycin. Each colony contains the recombinant plasmid by their ability to grow in the presence of apicillin in the agar. Fifth step, pick the colonies and inoculate a large culture to expand the plasmid carrying the gene of the interest. Sixth step, gonna isolate and clean the DNA from the expanded culture. So the last step, we're gonna transfer the plasmid DNA to desired cells like bacteria, yeast, mammalian cells, and test the biological properties of the gene of the interest. And these are the picture for the recombinant DNA, and they show the steps of the 7 steps of the recombinant DNA. We want to know what the uses and the aims of the recombinant DNA. Recombinant DNA is used to identify and map and sequences genes and to determine their function. rDNA probes are employed in analyzing gene expression with individuals, cells, and throughout the tissues of the whole organisms. Thank you for watching and for your time.